So I am Girish Setlur. I am the instructor of this course. So how many of you have actually registered for the certificate? I'm just curious to know. Nobody?
Not yet, sir.
Not yet. When is the last date for that? I don't know. Okay.
Till September.
Okay, never mind. Okay, so this is mainly for you to, it's meant for you to ask me questions about, does this still work if I remove my headphones? Can you hear me now?
Yes, sir.
Yes, sir.
Okay, good. I think these headphones are not needed. Yeah, tell me, what do you want to know? So basically, the latest assignment was purposely challenging because I didn't want you to think that this course was all about multiple choice. So I know that it was unfairly challenging because many of the questions were somewhat, I mean, considerably difficult. But you see, that is the standard at which this course is supposed to actually operate. But I'm noticing that I don't know. I mean, so judging by the statistics of the MCQs themselves, the number of students, maybe around 38 or something, 38 or 35 students submitted the assignment 1 and 2. That was multiple choice. And of those, half of them scored very less marks, which is very shocking. Because if you think about it, MCQs were only about this, just elementary background material, isn't it? It was just like prerequisite testing whether you know some very elementary physics. But that itself, many people didn't do well. So that is quite not acceptable in the sense that then you should really ask yourself if this is the course you actually want to register for, because maybe this is not the course for you. But at the same time, those of you who genuinely want to specialize in theoretical physics should make an effort to reach the level where they can follow what is happening in this course and in the textbook and in the exercises and so on. So I am making the solutions of assignment 3, and especially that cylinder standing vertically. That problem is very similar to that cube or that brick-shaped rectangular brick standing on a flat surface. That was a worked out problem in the textbook, if you recall. So there was a LX, LY, LZ shaped brick. So that was placed on a flat surface and that deforms under its own weight. So that was a solved problem. And this is just, I'm just changing the geometry from rectangular to cylindrical. So I thought you will be able to do it rather easily. But unfortunately, I'm noticing that many students have simply copy pasted the brick solution and presented it as the solution of the cylinder problem, which is completely not acceptable because the brick solution is already there as a worked out example in the text. So you can't simply copy. So that means you have no idea what either of them is saying because you have not understood the brick solution, you have not understood the question regarding the cylinder, and you're simply copy pasting one into the other. So you are not doing yourself any favors if you do that, because you're actually wasting your own time. So don't do that. I mean, if you don't follow and if you really genuinely want to understand, only then you should register for this course. Because otherwise, you're wasting your time. See, certificates, if you're only interested in certificate, there are much easier ways of getting certificates. You don't have to register for a course in quantum field theory to get a certificate. So if your goal is just to get a certificate, just register for some much simpler courses. So this is not the correct way of getting a certificate. There is too difficult a course for you to be interested only for a certificate. But if you are interested in the course and you have some genuine concerns about how the course is going, I saw those two criticisms on that was sent to me. Saying one of them said that actually both said that they prefer a blackboard teaching. That means they want me to write on a blackboard. I know that IIT Madras has some very famous professor like Valki and those type of professors who actually speak in front of a classroom, a traditional classroom, and they write on the board. And yeah, that works too. But then you see firstly, that works if your goal is to teach rather elementary things at a leisurely pace. So you don't, you don't spend a lot of time getting into very difficult or like detailed things. Because this whole book is actually crammed with information. If you see that it covers the entire gamut of classical and quantum field theories. So it is rather. The learning curve is very steep, and it's a very dense book, and it's hard to swallow in one go. So in fact, one of my students, PhD students, he himself said this, that it's better to actually break this course up into two pieces. The first piece will be classical fields, the second will be quantum fields, two separate courses. That may be a good idea. But then, you see, the thing is that, no course actually can do justice to any subject, because finally what happens is that classroom instruction can simply not be a substitute for self-learning, because finally physics is learned. All these difficult subjects like physics, maths, and all those things, they are learned by yourself. That means yes, self-learning is the only proper way to learn. What classroom teaching does is it just points out to you that these are the things worth learning. It just says what things are worth learning. Because you see, when I was growing up, we did not have this access to all this information, internet, Google, and all that. So we were struggling even there. We had no access to resources to learn. But now you have that issue is simply not there in your case, because you have all the information is available at your fingertips. It's just that a lot of garbage is along with the important information. So somebody has to tell you these are things worth learning. So that is the only purpose, according to me, of any classroom instruction in the 21st century. And that is for the teacher to just make the students aware of the ideas that are important, that are worth learning, and that form some kind of milestones in the field. That it just points out these are the milestones, and this is where you have to go from here. So so that's the thing. So those are my thoughts about this course. So the complaint that I have to teach on a blackboard would have been a valid complaint if the textbook that I am following was somewhat less dense and or considerably less dense, and it covered slightly more elementary topics. Because many technical, very detailed technical topics are not easily taught in a classroom setting. They are best taught through exercises. In fact, that's the reason why I assigned exercise. That is, the assignment 3 was purposely it was not an MCQ. It was a subjective question, and it simply picked the questions from the end of the chapter, which are meant to be challenging. And if you are able to reach that level, where you can properly, correctly solve the questions in assignment 3, then you can be very satisfied that you have understood the course. So that should be your goal. So I am teaching this course largely from the point of view of just making you aware of the things in the textbooks that are important that you should know, and I'm just just augmenting the textbook. So in fact, that's the reason why some of you are not happy. You are saying that why do I need instruction when all I'm doing is reading off from the textbook. I'm not merely reading off from the textbook. I'm actually clarifying certain things that are there in the textbook over and above what's written there. Meaning, it's for you to decide whether that has been beneficial to you or not. But I don't think it's a fair characterization to say that I'm simply reading off the book. I'm actually doing more than that. But in any case, the thing is that as one of you also pointed out in that comment section, that it is true that I am constrained, and one of you understood my constraints also, because IIT Guwahati does not have that classroom system where I just go in front of a blackboard and teach, just like Balakrishnan of IIT Madras. There they have that system. In IIT Guwahati, we have this tablet system where I just write on a tablet. So yeah, so those are the constraints that we are also facing. So, and there are plus points to classroom teaching and negative points also. Similarly with tablets also, there are plus points and minus points. So you have to see, if your goal is to learn the subject, you should work around those constraints rather than dwell on those constraints. So anyway, tell me about your concerns. Right now, those are my thoughts regarding the course. So if you feel you have something to say, just don't be afraid, because this session is all about free exchange of ideas, and whatever suggestions you make will be very valuable. Because in fact, the textbook that I wrote was largely because of the suggestions I got from IIT Guwahati students. So they were constantly complaining, sir, I am trying to understand this research topic. This type of thing is not there in any course. Nobody taught me this, nobody taught me that. I'm struggling, I'm not able to understand. And so many students fall back in their research because they are not able to follow many of the things. So I wrote this book primarily to fill those gaps, just to say, for example, this energy momentum tensor. So those of you who work in general relativity, you will constantly be reminded that there is something called energy momentum tensor. And those of you who don't know what that is, and like you might be thinking that why energy momentum, that seems like a 4 vector, why should there be a tensor there? So I mean, so those are natural questions that people will have. And I remember that when I was learning also, I had similar questions, that there were lots of reasons why I couldn't understand general relativity very easily. One of them was why do you need a rank 2 tensor? So these types of things. So I have just introduced these concepts just to make you aware of those issues. So things which I feel are not well covered. The other one is like this dynamical symmetries. That means that there is Noether's theorem, which says that every conserved quantity there is is derivable from some continuous symmetry. But the question is, that there are certain conserved quantities for which the symmetries are not particularly obvious. Usually, it's the other way around. The conserved quantities are usually less obvious, and the symmetries are easy to guess. For example, rotational symmetry, translational symmetry. All these are very easy. They're like aesthetic and they're very visual in their nature. So it's easy to imagine those symmetries. So, but then the fact that there is a conserved quantity like angular momentum is less easy to guess, or linear momentum if the system is translationally invariant. So those are less easy to guess, but then the point is that Noether's theorem makes this connection, so it becomes very convenient to guess the symmetry, because that is very intrinsic to humans to spot patterns and that sort of thing. But the only exception is this peculiar conserved quantity in the case of inverse squared interaction called the Lungia lens vector. See, there both are difficult. Not only is it very hard to stumble upon this vector that is conserved, and not only is that difficult, it is even more difficult to explain which symmetry leads to the conservation of the Lungia lens vector. So both are difficult, and that's the reason why that is completely skipped in many of the books. And my goal was to make you aware of the existence of not only the conserved quantity, but also the symmetry associated with it. Okay, so there are many things in the book which I feel are purposely included to fill gaps which are otherwise present in the presentations of others in the same subject. Okay, so it's kind of meant to complement what is out there. So also true with the concept of right movers and left movers in the context of this condensed matter physics, especially the so-called theory of Lungia liquids. So if you want to do research in low-dimensional quantum physics, then you will encounter something called Lungia liquids. So those the low-energy physics is dictated by what are called right movers and left movers. And there is a simple way in which you can make sense out of those concepts. And that is not typically well explained in the textbooks. So those are usually research level review articles. So I have tried to include them at that level of textbooks. Okay, so there are many things in the book which are purposely there to complement what's already out there. Okay, so it's kind of so this book is kind of meant to act as something. You already learned similar things from more traditional sources, and those traditional sources miss out a whole bunch of things, and then you register for my course and fill those gaps. So that's the whole idea of this course. Okay, so does anyone have any comments, suggestions, criticisms, etc., etc.? So just go ahead and say what you want to say. Hello, can you hear me? Say, yeah, please. Yeah, I'm able to listen to you. At least I can see you, but if you say something, I can hear you. Does anyone have anything to say? Do you have any question, comment, anything? So this is just an interactive session where you are, you are encouraged to, voice any concerns, questions, etc. you may have, because you are spending your valuable time on this course, isn't it? So you should, if you feel it's a waste of your time, you should basically ask yourself, maybe you should register for something else. But if you genuinely want to learn this course, then you should register and try to do the assignments, etc. So I will be uploading the solution of assignment 3 very soon, and I'll probably also record myself solving those problems and upload them as a video, because I think they're sufficiently interesting and not that easy, so that a kind of a recorded description of those solutions will be important for later, uh, you know, versions of this course also, and also whoever wants to, search on Google and stumble upon these ideas. So yeah, so I'm doing this for not only the present course purpose, but also for posterity's sake. So I want to keep them as archival values. So I keep them, stored as some ready-made solution of interesting problems, and it'll be there on YouTube forever, so anyone can search and find it.
Surely, sir, we'll do that.
Sorry.
Surely, we'll see that.
Yeah, you should. I will upload solutions of the third assignment, and you can have a look. Yeah, so I don't, I mean, look, you don't have to necessarily feel too bad if you didn't do well in assignment 3. That was purposely difficult and actually considerably difficult. And I don't blame you for that, because many of the questions are purposely vague. Sometimes some of them are purposely vague because I have said in my preface to the book that being able to rephrase the question in such a way that you can, the question makes sense, that also is part of doing research. So some of them are not, I mean, they're not that vague, but still I could have included more information. But nevertheless, I don't worry about marks and all that. I will be very generous, especially in assignment 3. I'll be very, very generous, because I know that it was especially hard. And I will upload the solution, then you can have a look. Okay. Yeah, somebody
Sir,
wanted to say. Yeah, sure.
sir, I have a request that the Euler-Lagrangian equation and the Hamiltonian equations in your book cannot channelize in a simple way by me.
So sorry, can you please repeat that?
Sir, I want to say that the in your book the Euler-Lagrangian equations and the Hamiltonian equations
Yes.
that will be not channelized in a simple way by me. That I want to channelize in a simple way.
Yeah. So that means you were not happy with the presentation of those topics in my book. That is understandable. Because, no, I mean, see, first of all, the first chapter is a kind of a review. It's not meant as a substitute for Goldstein or something. So those traditional books, which point particle mechanics is a prerequisite for this course. Okay. So point particle, Lagrangian mechanics, Hamiltonian, those are not part of this course. It's a prerequisite. So I'm just reminding you of all those ideas that things you are supposed to know. But yes, I mean, your more general question is that you want to visualize it. So I thought I had made an effort to make a geometrical description of the Hamiltonian. Did you follow that? In fact, that is also not well explained in pretty much any book. So that the Hamiltonian has a geometrical meaning. The Legendre transformation is a very geometrical transformation. So it's like, if you have a curve, so you can describe a curve by specifying the x and y values, isn't it? So that's one way of specifying a curve. The other way of specifying a curve is don't specify the x and y points, but instead you write down a lot of straight lines and say that the curve is that curve which is simultaneously tangent to all those straight lines. So that means that you will be, if you collect this correct set of straight lines, you will find that there is exactly one curve that is tangent to all those straight lines at different points. So that will also, so in other words, the collection of straight lines will itself describe that curve indirectly. So that that collection of straight lines approach is basically called the Hamiltonian approach. Okay. So the Lagrangian approach is the one which specifies x and y values. So in this case, x means v, which is generalized velocity, and y is Lagrangian. So specifying v and lv is the usual way of doing Lagrangian mechanics. The Hamiltonian mechanics is specifying the tangents to that curve. So if you specify a bunch of tangents and you say which is that curve which is simultaneously tangent to all those straight lines, so that also uniquely specifies L versus B. But then indirectly through the specification of those straight lines, the straight lines are basically the Legendre transforms. So the vertical intercept, right? Then the y-intercept is basically the negative of the Hamiltonian, the y-intercept of that straight line. So it has a very deep geometrical meaning. So the Legendre transformation which gives you Hamiltonian, and the Hamiltonian itself has a geometrical meaning as the negative of the y-intercept of the tangent. Okay. Yeah, so that's very interesting and important, and it's not usually explained in the books. So that's
So
worth learning. Yeah.
So I think at this level, I have to require the basic books for such type of mathematics. So if you suggest me,
Now, which type of mathematics? Y equals mx plus
basic,
c. No, straight line. Straight line means why you need any book. So tangent,
no,
straight
sir.
line. I mean, these are all very like 8th standard, no? So tangent, straight line. See, you have to understand the connection between. Did you follow what I'm saying? I mean, maybe my Hindi is not very good. I can speak in Hindi if you want. You know, a curve hai, so you want to describe that curve, instead of describing by curve, you want to describe a straight line, right? So how
Yes,
to
sir.
describe a curve by straight line? You cannot describe by one straight line. So you can describe by many straight lines. So you write down many straight lines and draw a curve which is tangent to all those straight lines at different points. So you can
Yes, I got
describe one curve by many straight lines. So that is basically Legendre transform,
okay.
isn't it? It's not that
Yeah,
difficult if you think about it. So any other comment, criticism, question? Are there any other questions, comments? Yeah, if you don't have anything, we can disperse. But if you have something important to tell me, you just have to tell me now.
No, sir, at that point, I have no more question.
Okay, so what about the others? Yash, Saurabh, Anushman, Ayan, do you have any questions or comments or whatever? Anything? So can I ask you, like, why? What is each of your background? Like, Ashish, what is your background?
Sir, currently I am studying BSc from Bihar.
Bihar, and You want to specialize in theoretical physics, or why are you enrolling in this course basically?
So before it, I enrolling in classical mechanics that were taught by A.C. Burma, sir.
Okay.
And I am much more interested in electrodynamics and classical mechanics.
Yeah, but this is not electrodynamics or classical mechanics. This is field theory. It's a very advanced course. So, do you feel like so you want to see this course is for people who want to do PhD in theoretical physics later on. Not now, but after BSc, MSc, and all that. So, are you interested in theoretical physics?
Yes, I think if I try furthermore, then
Yeah, I mean, you
I will
made
do
a
better
choice.
in it.
It's like this. I'm not discouraging you. It's just that I'm saying that, if you want to do research in theoretical physics, it is very important. I also learned many things quickly on my own by reading from libraries and all that. So now that you have access to other types of material online and all that, it is very good that you start early. See, just like in JEE preparation, no, like kids these days start at 8th standard or 7th standard, like that. They'll start JEE preparation. It is very horrible, but those people actually finally are able to crack that, because even though they'll be sacrificing their childhood, they cannot play with their friends and all that, but finally they will get into IIT or something. Whatever they wanted, they'll get, but they will have to pay a very heavy price. But that is a decision you have to make at a personal level. So similarly here also, if you want to do great things in research, because research has progressed a lot now, there is too much to learn. So the human lifespan is only 60, 70 years, and your brain will work for the first 60 years maximum. After that, your brain will stop working. So the point is that if you want to do great things before 60 years, then you have to learn a lot. And earlier you learn, better it is. So what you are doing is the correct approach, in the sense that if you want to do theoretical physics, you have to start learning advanced things at an earlier age. So which is exactly what you are doing, which is very good. But you should
Yeah,
seriously
that
ask yourself, if that is really what you want to do, you are exactly doing the correct thing. But just like those kids who are preparing for JEE, but it will come at a very high price. That is that they will be sacrificing their childhood. They will be constantly studying, not doing anything else. So it has plus points and minus points also. So if you
yeah, sir.
want to
I already missed J chances in my at
yeah,
yeah in when I have 12.
yeah, this is same as that type of work only. Means instead of studying for JEE, you are studying for Nobel Prize. So same thing. It is the effort is even more actually now. If you want to do big great things, you have to start very early. Just like if you want to crack JEE, you have to start at 7th standard. So if you want to win Nobel Prize, you have to learn quantum field theory when you're 18 or something. So yeah, that's how it works. So you're doing the right thing, but I told you, no, it's a personal choice. So nobody is forcing you to register for this course. If you have registered it on your own, that means you are genuinely interested in specializing in theoretical physics. If you are, then you are in the right place. You're most welcome. But if your aim is simply to get certificates, there are much easier ways of getting certificates. Yeah, tell
No, sir.
me.
I am enrolling in fifth more courses in NPTL. My last chance is not to get certificate. I just want to learn.
No, I don't want to be condescending. I'm not being condescending. I'm just like stating a fact that there are many students who kind of are fishing for certificates. I know that for a fact, because there are some in my family who do that themselves. So yeah, so I disapprove of that type of an approach. But nevertheless,
because
you are
there are
in the right place. I mean,
also
you
problems
made the
that
right choice. Yeah. Yeah. Somebody else wanted.
sir,
Yeah. Tell me.
Hello, hello, sir. Sir, I wanted to do PhD in theoretical physicist or do research in string theory, but I don't know how to go. Right now, I'm doing MSc.
Yeah, so whatever branch of sub specialization of theoretical physics it is, some basics are always required. That without basics like field theory, classical mechanics, stat mech, and all these things, without a basic knowledge of theoretical physics, you cannot do anything great in theoretical physics. So these are all considered very core, basic. Courses in theoretical physics. So if your goal is to do PhD in theoretical physics, you should be paying attention to these types of courses, no doubt. Doesn't matter which theoretical, whether it's string theory or condensed matter or high energy phenomenology or anything else. Yeah, so what about the rest of you? So I wanted to know the background of Yash. Oh, he left. So what about the rest of you? Saurabh, Anshuman. So what are your backgrounds?
So I'm doing MSc in physics right now.
Sorry?
MSc,
You're doing MSc where?
sir, RML College, RML University, USD.
Okay. And Anshuman?
I'm doing a physics honors from Doon University.
Sorry?
Physics honors, sir, Doon University.
What, MSc or BSc?
BSc, sir, BSc.
PhD, okay. Yeah, so you will probably be better equipped to handle this course because you have some background. So nevertheless, it's important for everyone to put in effort, including me actually, because the effort, I'm noticing that for assignment 3, the effort required to do it properly and write the solutions in a way that others can understand is considerable. So I'm having to spend a lot of time typing that solution. So I'm close to being done. I'll probably not, the last question, though the sphere is entirely analogous to that, means the procedure is very similar. So I'm going to stop at that rod standing vertically. So the rest you should be able to handle. See, if you think about it, it's a very elasticity theory is a very interesting topic, isn't it? Like you have this heavy rod that is standing vertically. You want to know how it deforms under its own weight. That's an incredibly interesting question, which every lay person can understand that it's an important and interesting question. But its solution is anything but simple. So it requires a detailed understanding of elasticity theory. So that's the reason why I have included all these topics. I mean, this could be terribly important, in this, when people are thinking of building structures on other planets and even within our own planet. I mean, if you want to build gigantic structures like, like the Burj Khalifa or something even taller than that, you have to understand how, these heavy structures deform under their own weight. So it's not at all unimportant. It's quite important to know these things. So I mean, if you know this sort of subject, then you can develop some packages or something which can help some architect or civil engineer, because those guys may not have such a deep understanding of elasticity theory that you get from a field theory course. So if you learn this properly, you can probably, create some simulation package which behind the simulation will be all these equations of elasticity theory, and then it will help an engineer or an architect visualize those structures and see if they will collapse under their own weight or they'll break or something. Those type of issues you can address through these types of ideas. So if you acquire this knowledge on your own, you can create many products which you can probably sell in the market. You know, you can create a package and say that this will be useful to a civil engineer trying to build a skyscraper. So things like that, you know, I'm sure some of it is already available, but it's just that you can probably do a better job if you first figure out what's available, then you have your own fundamental knowledge of elasticity theory. You combine both and see what's missing. You put in things that are missing in those packages, improve upon it, and you can start your own company. You know, this is the startup culture. Our government is now encouraging people to not seek government employment but create startups. So this could be one startup that you can do. All you have to do is invest intellectual capital. You don't need you don't need money for this sort of thing. You can make a lot of money, but the investment is purely intellectual. Those types of opportunities are very limited, by the way. In most of the time, to make money, you need money. But there are few examples where you can actually make money. I'm not guaranteeing that you'll make money. I'm just saying that there is a possibility that if you invest properly and if you invest intellectual capital in a clever way, you can make tons. Just like Bill Gates did in his early days. He didn't have any money. He just had an idea. So pretty much any idea which is important, you can convert it into a product if you're clever enough. And that's something you should do. Indians traditionally are kind of averse to we don't have that entrepreneurial culture. We always look for government jobs. In other countries, they're not like that. They just go out and create their own companies, and society progresses considerably because of that. So society doesn't progress too much because of people like me. Progresses because of entrepreneurs. So you should also think along those lines. So it's not merely to acquire knowledge for its own sake, but you should be able to apply it and benefit society. So you should do both, right? So there's no harm in doing both. Okay, so do you have any other question?
So can I ask in Hindi?
Sure. I know Hindi, means I understand Hindi, but I don't speak very well.
सर मैं ये बोलना चाह रहा था कि अगर बीएससी के बाद रिसर्च में जाना हो तो सबसे इजी वे क्या होगा उसके लिए?
बीएससी के बाद वो क्या होता है कि बहुत सारा जगह में वो 4 साल का मिनिमम जरूरत है. 3 साल का बीएससी से नहीं चलेगा मेरा हिसाब से, डायरेक्ट पीएचडी एंट्री. तो नहीं तो एमएससी करना पड़ेगा, नहीं तो वो बीटेक टाइप का कुछ करना पड़ेगा. बीटेक करने से 4 साल हो जाता है ना. तो वो अमेरिका में भी ऐसे ही है, 4 साल के बाद डायरेक्ट पीएचडी एंट्री होता है, नहीं तो नहीं होता है. वो 3 साल के बाद कहीं पे नहीं लेता है डायरेक्ट पीएचडी, टू द बेस्ट ऑफ माय नॉलेज. बट आईआईएससी वगैरह में वो इंटीग्रेटेड पीएचडी होता है. वहाँ पे 12th स्टैंडर्ड के बाद डायरेक्टली बीएससी पीएचडी ऐसा हो जाता है एक साथ, मुझे लगता है. मैं ठीक से नहीं जानता हूँ उसके बारे में. बट जनरली 3 साल बीएससी के बाद डायरेक्ट पीएचडी एंट्री बहुत कम जगह में होता है. मींस एमएससी करना पड़ता है. दैट इज
Sir, I have general question. Can I ask?
Yeah, tell me.
Sir, let's suppose anyone standing between two parallel mirrors.
Sorry, your voice is extremely unclear. So can you There's something, some voice in your background also. Can you switch that off? Yeah, you can speak now. Let's see. Are you using your mobile or something?
No, sir.
Okay, try saying something because maybe you should stay away from the microphone a little. If you're too close to the microphone, it kind of creates some echo. Try staying slightly away from your microphone and speak. Yeah, I'm listening. Tell me. Do you have any question? Anybody has a question? Comment, question? Anybody has a question, comment? I can spend a maximum of 10 more minutes. After that, I'm leaving. So if you have a question, please let me know now. So everybody is silent. Does that mean you don't have a question, comment? So if you don't have anything, I'm leaving. Anybody has anything to say? Anybody has question, comment, anything? Any difficulties you're facing over and above the obvious ones? Did you, meaning I was not aware that the assignments were corrected and sent to you. So how did you receive your first and second assignments? Means did you receive through email or there was some link which you had to click? How did you come to know of your marks for the first and second assignments? Hello, can you hear me?
Hello, sir. Now I'm audible.
Yeah, you're audible from the beginning. It's just that there was some disturbance. Yeah, tell me.
Sir, I wanted to ask, let's suppose if I'm standing between two parallel mirrors and there are infinite images are formed, right?
Two parallel mirrors.
Yeah, I'm standing between two parallel mirrors, ideal
Yeah.
parallel mirrors, let's suppose.
Yeah.
So there are infinite parallel images are formed.
Sure.
So if I remove from that, is the image is still in the mirror or not? Maybe the size is small, but
I
I
didn't
think I am.
follow. What did you remove?
If I remove between the mirror myself.
You remove yourself.
Yes, sir.
And you're asking if your images will still be there.
Yes, sir.
Yeah, I mean, that sounds like a philosophical question. You know, does the moon exist when you're not looking? I don't know. I mean, the obvious answer would be obviously not, because once the source of the image is gone, the image is
But
gone.
but the speed of light is finite and it takes times to cover the distance.
Okay, I got it. So what you're implying is that
I'm trapped is in the mirror.
no, but then you see, notice that it's a virtual image. So the
Yes.
image it's not a physical object, right? There's no such thing as does the image exist? It doesn't exist as a physical object. It is just an effect of the light that is bouncing off your body and reflecting off the surface of a mirror and creating an illusion of there being another you on the other side. So it's a kind of an illusory effect. So if you remove yourself from the situation, and so you're asking that if somebody else, I don't know what. Sure.
But my first image is. Can I speak in Hindi?
Sorry. Yeah, Boli. You can speak in whatever language I understand, which is Hindi, English, Tamil, Telugu, Kannada. These are the language I understand. I don't speak very well, but I understand.
सर मतलब मेरा कहने का मतलब ये अगर दो पैरेलल मिरर के बीच में अगर मैं खड़ा हूँ तो उससे इन्फिनाइट इमेजेस बनेंगे तो जो पहली मेरी इमेज होगी वो दूसरी इमेज बनने की रिस्पॉन्सिबल होगी है ना ऐसे पूरी प्रोसेस मान लो टी टाइम लग रहा है 10 मतलब हजारवीं इमेज को बनने में जब थाउजेंड्स तो अगर मैं वहां से हट गया
समझ
तो
गया तो मतलब दूर में जो इमेज है वो बहुत टाइम लगेगा बनने के लिए ऐसा
हाँ सर हटने उतने हटने में भी टाइम लगेगा ना सर क्योंकि जितना बनने में टाइम लगा लाइट को वहां तक पहुंचने में उतना वापसी इंफॉर्मेशन को ट्रैवल करने में तो उतना टाइम लगेगा ना दोबारा
ऐसा मत सोचिए ऐसा नहीं सोचना चाहिए क्योंकि क्या होता है सी ऐसा नहीं है कि वो जो हाँ मैं समझ गया आप क्या बोल रहे हो सी ये जो इन्फिनिट इमेजेस जो बन रहा है ना वो ऐसा नहीं है कि वो मतलब इट्स नॉट लाइक वो उसका पीछे जो आदमी खड़ा हुआ है जैसा लगता है ना वो आदमी से लाइट जाएगा और इतना दूर तक ट्रैवल करेगा और वहां तक ऐसा नहीं हो रहा है असली में सी क्या असली में क्या होता है सिर्फ लाइट इज बाउंसिंग ऑफ द मिरर्स व्हिच आर जस्ट इन फ्रंट ऑफ यू तो वो दैट इज जस्ट एन अपेरेंट इफेक्ट ऐसा लगता है कि वो बहुत दूर से वो कोई वहां वो मिरर्स का पीछे जो आदमी बंदा खड़ा है उससे लाइट आ रहा है ऐसा लगता है ऐसा असली में नहीं हो रहा है असली में क्या हो रहा है लाइट सिर्फ वो सरफेस ऑफ द मिरर जो तुम्हारा सामने ही है उसमें से मल्टीपल रिफ्लेक्शन होके ऐसा महसूस होता है असली में वो वहां से नहीं आ रहा है वो ऐसा लगता है तुम्हें ऐसा आ रहा है क्योंकि इट्स मतलब तुम्हारा आई में जब जाएगा ना तो मेरा ब्रेन ऐसा इंटरप्रेट करता है ऐसा हो रहा है बोल के, ऐसा लगता है तुम्हें ऐसा हो रहा है, असली में ऐसा नहीं हो रहा है। असली में क्या हो रहा है, लाइट सिर्फ तुम्हारा शरीर से जाता है, वहां पे सामने जो मिरर है उससे रिफ्लेक्ट होता है, इससे भी रिफ्लेक्ट होता है, और ऐसा मतलब तुम्हारा मन में ऐसा इमेज क्रिएट करता है, तुम्हारा ब्रेन और तुम्हारा आई का जो ऑप्टिक नर्व सब मिलके ऐसा इम्प्रेशन क्रिएट करता है। वो असली में उतना दूर तो ट्रैवल नहीं कर रहा है। मतलब हम लोग उसको रे ट्रेसिंग करके ऐसा बनाते हैं जैसा ऐसा लगता है कि वहाँ उतना दूर से आ रहा है, असली में तो वहां से नहीं आ रहा है, वो नजदीक से ही आ रहा है। वो
दूर वाली इमेज में सिर्फ कैसे दिखती है, मतलब वो उसमें क्या होता है फिर जो मतलब
ऐसा नहीं है कि वो दूर में कोई असली एक बंदा खड़ा है, उस बंदा का शरीर से लाइट निकल के आ रहा है, ऐसा नहीं है ना। वो बंदा है ही नहीं वहां पे, है कि नहीं। वो बंदा हमारा मन में ऐसा क्रिएट हो रहा है, हमारा मन में लग रहा है कि ऐसा बंदा खड़ा है वहां पे, असली में वहां पे कोई खड़ा ही नहीं है। मतलब उस बंदा से लाइट आने का सवाल ही पैदा नहीं होता।
समझ गया सर।
So any other question?
और सर एक और क्वेश्चन था। सर लेट सपोज अगर मैं किसी बॉल को डीप स्पेस में थ्रो कर देता हूँ, तो सर क्या वो बॉल कभी रुकेगी?
डीप स्पेस में कोई बॉल फेंका
कुछ इनिशियल फोर्स के साथ?
हाँ, वो न्यूटन्स फर्स्ट लॉ क्या बोलता है, एक बार फेंक लिया तो चलते रहेगा जब तक कोई आके नहीं उसको पकड़ेगा।
लेकिन सर स्पेस प्योरली एम्प्टी तो नहीं है ना?
स्पेस
सर जो स्पेस जो वैक्यूम है वो प्योर एम्प्टी थोड़ी ना होता है। दे हैव सम काउंट ऑफ क्वांटम फ्लक्चुएशन पार्टिकल्स, मतलब जो बनते हैं और खत्म होते रहते हैं।
नहीं, वो जो भी फ्लक्चुएशन हो, न्यूटन्स फर्स्ट लॉ
नहीं, मैं कह रहा हूँ कि वो फ्रिक्शन प्रोवाइड होगा ना। मेरा कहने का मतलब है कि उस बॉल पे फ्रिक्शन आएगा ना उनकी वजह से, क्योंकि कोई भी चीज स्मूथ नहीं हो सकती प्योरली।
कोई एक्सपेरिमेंट के बारे में नहीं सुना जिसका वजह से न्यूटन्स फर्स्ट लॉ वैक्यूम में वायलेट होने का संभावना।
थ्योरेटिकल क्वेश्चन आस्किंग, जस्ट
आपने
थ्योरेटिकल क्वेश्चन आस्किंग।
देखा है ऐसा कुछ ऐसा होता है बल्कि मैं तो नहीं देखा।
नहीं सर, जस्ट आई एम आस्किंग थ्योरेटिकल क्वेश्चन।
To the best of my knowledge, the answer is no. I mean, vacuum fluctuations will do little to prevent, or it will certainly not make first law of Newton violate the first law.
But sir, Newton first law is not violating if external force is acting on it. Because
no, there are no forces, right? You just ejected a projectile at some constant velocity in some direction. Why would it come to a halt?
Because sir, space can provide friction.
Listen, there are two things. First is, you have to assume that Newton's first law is a classical physics statement. So if you assume that the thing that you are ejecting obeys classical mechanics, there is absolutely no chance of it coming to a halt at all unless something blocks it or stops it in its tracks. So, so the Newton's first law has nothing to do with quantum mechanics. So, you're confusing a whole lot of things. You said quantum fluctuations, but in the same breath, you're talking of Newton's first law. Newton's first law is applicable to classical mechanics. So, if anything that obeys classical mechanics will be immune to the effects of quantum fluctuations. I mean, if anything so large that its classical mechanics is applicable to its description, like a tennis ball or a cricket ball, quantum fluctuations have absolutely no effect on such systems.
But I'm saying the friction is very small, but it is there. I'm not saying zero. Maybe the space provide any kind of friction. I don't know its value, but
so you are saying that suppose instead of a cricket ball, you imagine say quantum particle like an electron.
Yes, sir.
and if its energy is greater than 2 mc squared, there will be pair production. There will be production of electron positron pairs just from the energy. No, I think even that is not possible because that would violate. See, energy and momentum have to be conserved. So you can't have pair production. Anyway, you can't have pair production.
सर
You'll end up
अगर ऐसा होता तो
no, you'll violate either energy conservation or momentum conservation. You can't have a single particle losing energy and producing pairs. In fact, that's one of those classic questions in special relativity courses that we teach. So
Sir,
you need to you need collisions, or you can't really do that. You have to conserve energy and momentum together. So you can't really do that.
I'm saying कि सर जो स्पेस है वो पूरा empty नहीं है ना, कुछ ना कुछ तो होगा वहाँ पर भी, क्योंकि nothing क्या है.
Sir, if it happens,
Look,
if it happens, so then electromagnetic.
Listen. You should not make the mistake of thinking very casually and in a very lazy way like that. Say ऐसा हो सकता है, हो भी सकता है, नहीं भी हो सकता है. ऐसा फिजिक्स नहीं चलता है. तो एक जगह में बैठ के पेन पेपर निकाल के कैलकुलेशन शुरू करो कि देखो सब कंजर्वेशन लॉस लगाओ, एनर्जी कंजर्व होना चाहिए, मोमेंटम कंजर्व होना चाहिए, सब कुछ कंजर्व होने के बाद ये ऐसा प्रोसेस होता है कि नहीं. देखो मेरा हिसाब से नहीं होगा ऐसा. कुछ प्रोसेस नहीं होगा जिसका वजह से उसका मोमेंटम सडनली कम हो जाएगा और कोई पेयर प्रोडक्शन. सो दैट विल वायलेट मोमेंटम कंजर्वेशन. So which is by the way also sacred in quantum mechanics. So momentum conservation is sacred both in classical and quantum mechanics.
Sir, I think if it happens so, then electromagnetic theory will be also cannot stand.
Sorry, electromagnetic theory
will also cannot stand if in a space someone quanta particles loses their energy.
No, I don't follow what you're saying, but whatever it is, my strong advice to all of you is learn to think like a physicist. A physicist does not ask, ill-posed questions like that. So your question you have to ask should make full sense, and it will make full sense only if you accompany your answer one way or the other. See, suppose you decide to answer yes or no, you have to accompany that with a detailed calculation which tells you why the answer is that. Okay, so I have so the person who's asking the question has the best understanding of what they have in mind. Since you're the one who's asking the question, I strongly urge you, since you know exactly what you want, you sit down and work out the process that you want to see take place. So imagine that you want this process to happen in nature. Okay, suppose you want an electron that's moving at a constant velocity in some fixed direction to suddenly decelerate, and then you want that energy to be converted to something else, so that you want that friction effect to be imposed upon that electron. So you want the electron to somehow slow down gradually, continues to move in the same direction, but it slows down. But then what happens to the extra energy? It's converted to other particles through pair production. Suppose that is the process that you want to see happen. Then if that is the process you want to see happen, you work that out fully. You ask yourself, does that process conserve both energy and momentum? Okay. So if it does, then it's guaranteed to happen. So in fact, there is this famous quote from Feynman, I think, that in particle physics, any process which is not forbidden will certainly occur. Okay, but it may occur very rarely, but it will certainly occur. And there will be probabilities associated with certain processes. But then if it's not forbidden, you will always mean, there is no situation where a process is not forbidden, which will simply not occur because of some whim of nature. That will never happen. If a process is not forbidden, even if it's rare, it will still occur. So, but then in order for this process that you're thinking of to occur, namely an electron that is constantly, it's moving with a constant speed in a fixed direction, and you want it to all of a sudden change its speed to something much less, and you want that extra energy that's lost to be converted to other particles through pair production. If that's what you want, then you should work out the details of that process to see if that process really conserves not only energy, but does it conserve linear momentum. So my guess is no, it doesn't. It will not conserve both. And if it doesn't conserve both, that is strictly forbidden. It won't happen. Okay. So does anyone have any other question? I have to actually go now because it's already 4:10. So if you don't have any question, I'm stopping. Okay? Are we done?
Okay, sir.
Okay then. Okay, all the best. Don't worry too much. Just try to enjoy this course and try to do assignments as best as you can. And so if your goal is to specialize in theoretical physics, you're in the right place. Else you should look for some easier course. Okay? All right. See you then. Bye-bye.
Okay. Thanks a lot.
Yeah.